This conference will now be recorded. This conference will now be recorded.
Hello friends, welcome to the demo session on data science. Just give a minute for everybody else.
Okay, sir.
All right, so let me start our session today. My name is Sitaram and I have around 15 years of experience in IT, and for the past 10 years I'm into the data area. I worked as a big data architect, and for the past 5 years I'm working as a data scientist in one of the MNC. And I have good experience in machine learning, data science, and I also have a great passion in teaching. So that's the reason I've collaborated with different consultants, specifically Career IT, for doing this training program. And I have, from an education background, I have a MTech from BITS Pilani, and I'm pursuing my PhD from IIIT Hyderabad. And I'm a resident of Hyderabad. So these are some of the basic information about me. As we go deeper into the course, you would know more about me, and I would be knowing more about you. So this is some of the basics. Um, Today, our topic would be understanding the end-to-end life cycle of data science. So the focus is here is to understand like what are the bits and pieces, nuts and bolts which are involved in data science, and we go deeper in understanding like how it evolved, what are the main components of it, and how do I, if at all you are from a different background, say you are a DBA or you are a web developer or maybe you are a QA tester. So which areas are focus for us, what areas are important, what areas are not important. So all those things we will be discussing in today's session. Okay, so before I start the session, I just want you to provide some basic etiquette rules. So if you have any questions, you could use the chat window. There is a chat window. You could use the chat window and then put your question there. And if you have any real important question and you really wanted to speak, just take out time, and I will give some breaks in between where you can ask your questions, and we'll discuss about some Q&As. But mostly we'll keep it at the end of the session so that the topic is not disturbed. All right, so I would recommend everybody to use the chat window and acknowledge my questions, or you can ask your questions and so on, so that everybody will not be disturbed. All right, guys, can I get a yes? Can we start this session? I'll be using a notepad. So I have these notepads which I'll be using. We can write it here. You will be able to see what we are discussing. So today's topic would be end-to-end data science. All right, so end-to-end data science. So what we are focusing here is we are trying to understand, how it started, what are the major components of it, how it is evolving, what is the current state of data science, what are the important areas which we need to cover, and so on. So those are all the areas we are going to cover. So just imagine I'm talking about a basic retail company. Imagine there is a retail company which is selling some groceries, and we wanted to do some basic understanding of how many kgs of sugar sold, how many kgs of oil sold, and so on and so forth. So we want to do some basic processing of the retail data, and I want to understand those retail data. Typically, whatever transactions are happening in this retail company, they are stored in RDBMS databases. RDBMS databases, relational databases we call, or RDBMSs. And these kind of data sources are typically termed as ODS, operational data stores. So they are operational databases which are storing whatever is happening in the company. So imagine this is a small retail store, and we are storing all the whatever is happening in the company. So that small everyday data is getting stored into the RDBMSs, and that is getting captured. That's one part. Now, what we are also doing here is there is this entire retail data which is getting stored and uh, getting stored in databases. People wanted to understand or analyze on the data. Now imagine I wanted to understand last month how many kgs of rice sold, so that I can be prepared in this month, so that I can get the required supply, so that people will be getting the required bags of rice. So for doing that planning, I need to understand like what is the trend, how is the consumption of rice, either it is increasing or decreasing, if at all, which type of rice it is increasing, right? Is it a basmati rice increasing? Is it like a specific unpolished rice which is increasing, and so on? So based on these different kinds of patterns, I would like to plan my supply and demand. So for doing such kind of initial analysis, people used to run some SQL queries. So what are these SQL queries doing? These SQL queries used to run on these RDBMS databases, so that I can get something called as descriptive statistics. Descriptive statistics is nothing but I want to understand what happened in the past, last month, last week, last year, what is happening in the past. So based on the what has happened in the past, we can use the data for taking some decisions in the future. This is called as descriptive analytics, where based on the previous data, based on the analysis of the previous data, we will take some decisions in the future. So primary data analysis was more in the descriptive nature. I want to understand how many cars sold in the last year. I want to understand how many bags of rice sold in the last year. How many patients admitted in the last 1 month, right? How many of them are COVID and non-COVID kind of cases. So all these analytics, whatever we are trying to do, falls under something called as descriptive analytics. Are you understanding, guys? So what we are understanding here, let me take one example. We are taking example of a retail, and they will be storing the data, whatever is happening, the transactions which are happening in the retail industry, they are storing the data. But storages are called as RDBMSs, or operational data stores, ODSs. Whenever they want to do analysis on these operational data stores, they will run some SQL queries. So running some SQL queries, so they're getting some insights of the data. That is good. But this used to work for many years. Now this is what I'm talking about, history. So this used to work for many years. People used to run some queries on the databases and so on. But what happened is, as the business grew, so business primarily was focusing on US geography, okay? And as the business is growing, what is happening is the SQL queries which are running on the tables are hampering the real-time transactions. So whenever the transaction is happening, at the same time some queries are running, so which is slowing down the database, which is kind of hampering the performance of these transactions. They might be slow, the input transactions are getting slow. So somebody is actually purchasing, and then they are keying in the purchase data, then the billing is behaving slowly, the servers are responding slowly, and so on. Why that is happening? The reason it is happening is because that these particular applications, right? So these particular applications are running at the same time, the queries are running at the same time, which are slowing your front-end applications. Now what people did is, because they are slowing, these queries are slowing, they timed the queries to run as a nightly jobs. So instead of these jobs running in the daytime, now imagine this company is working in US. This is a US company, and they're working from 9 to 5. So during this time, these jobs are not running. The jobs used to run in the night. So they are nightly jobs. So the same SQL queries are created as jobs, and they were scheduled in such a way that they run in an off business hours. Not running in the business hours, they are running in the off business hours. So the business is not impacted. Now this is good, very, very nice. So these nightly jobs used to run for many years. What happened is, after a certain duration, with the advent of internet, with the advent of geographical expansion, so the company which used to be in US, now it has opened up the branches in every part of the world. So it has branches in Australia, it has branches in Singapore, Dubai, Europe, and India, and different places it has expanded. Now, and with also the internet, they have also launched the websites and people can order 24/7 and so on. So when both of these things have aggravated, when they have become the new norm, now this 9 to 5 was no longer prevalent, right? So there is nightly jobs which used to run in the night. They are not able to run at the night because at that time, while US is sleeping, Australia is awake, or Singapore is awake, or Dubai is awake, and they are doing transactions. So there was no such lean period where we are saying that this is the lean period where the transactions are at the minimum, right? So there is no such kind of lean period where such transactions are happening. So what we are trying to say is, the nightly jobs, there was no such period where I can run the nightly jobs. So to overcome that, what people did is they created something called as data warehouses. So what are data warehouses? Data warehouses are solutions. Now, data warehouses are solutions in which we are decoupling the operational data stores from the analytical data stores. Right? The data warehouses are primarily focused for running analytics. So we are decoupling the actual operational data stores from the analytical data stores, and I run the nightly jobs on the data warehousing, but not on the operational data stores. Are you understanding what is happening? So nightly jobs were not having the right time to run because the expansion of the business has happened, advent of the internet and other things. Now we are doing bookings 24/7. Now there was no such period that you can run these nightly jobs, and because of that, people started creating something called as warehousing solutions, which are like dumping your actual data into a warehouse, and you can run your queries on the warehouse rather than running on the actual databases. Now data warehouses has great advantages. Not only like it decouples the front end tables, but it also have the ability to store the data for different durations. The operational data stores are primarily storing the data as of today. As of now, whatever is the data, we have that in the operational data stores. But the data warehousing solutions can store the data, historical data also. For example, we can get the data of last year, last month, 10 years back also, we will be able to get the data. The advantage of that is now we can store such huge amounts of data where we'll be able to identify the change. We'll be able to understand the pattern difference and other things. All such kind of analytics could be done because now I have ability to store the data at different points in time. So that was a new norm. Many years data warehousing solutions were used. After that, what happened is, with the increase in a lot of data applications, now data warehousing were primarily focusing on structured data, more like a table kind of a data, row column data. So that is the primary focus of the data warehouses. But as the systems grew, there were new kind of data which were emerging. For example, images. I'm kind of drawing a mountain with the sun here and maybe a river, right? So we are having these images, we are having some video data, we are having some log data. So we are maybe having some sensor information. some IoT related sensors. We might have some textual data, some blogs and blog comment or whatever document, text data. So likewise, there are a lot of data, lot of different patterns of the data which are now available, right? So if you're only focusing on structured data, data warehousing solutions is good enough. But if I want to store images, if I want to store videos, if I want to store logs, operational logs, transactional logs, and other kind of logs, and if I want to store sensor data or textual data and similar kind of data, what happens is now you would require a storage which is capable of storing all such kind of solutions, all such kind of data patterns and varieties. So people created something called as data lakes. So what are these data lakes? Data lakes are primarily focusing on providing a storage solution for all this kind of data apart from structured data. So it will store structured data. Apart from structured data, we will also be able to store images, videos, logs, sensors, textual data, and other things. We will be able to store all these kinds of data, and we will be using some solutions like Hadoop for data storages. We'll be using some things like cloud providers like AWS or Azure or GCP and so on. Now, recently people have moved to these cloud providers, AWS, Azure, and GCP. But now what we're seeing here is we are able to use all these set of tools for doing all the operations, and it becomes very trivial to store all the data and then keep all the data securely, providing the storage capabilities and scaling capabilities, and we should be able to perform some operations on this data. So for that, we need to have some secure stored storage containers, which are called as data lakes. Initially, people used to use the HDFS file system, Hadoop, and other things. Nowadays, people are going to cloud storages. They are stored as blob storages, AWS S3, Azure blob storage, Google Cloud Storage. So these are some of the storage solutions which are able to store this data. Right, following what we are understanding? Are you guys following? Is the pace okay, guys? I just want to understand from you. You can use the chat window and then say yes. Right, so what we are understanding here is, given a use case, we are first understanding how the data was stored, what were the processings which were done, and how it came into the nightly process. Then we saw that the usage of data warehousing solutions, there are great advantage for the data warehousing solutions, but we saw that they are primarily focused on structured data. Now these structured data, instead of having the structured data, we are now able to see that we are able to store other types of data. We can store images, videos, logs, sensors, text, and all that stuff, and then put it into a storage solutions which are called as data lakes. So there is a lot of work here, right? So you need to dump this data. There could be some kind of integration tools here. There could be some kind of storage tools, real-time data ingestion, batch-based data ingestion, and so on. So this entire area, we call it as data engineering. You might have heard about this term, data engineering. Data engineering is the area which is used for doing the storages. It could be involving some kind of cloud. It could be involved in some kind of data ingestion, data transformation, and all that stuff. But primarily, the data engineer is somebody who is having an understanding of databases, who is having an understanding of file systems, cloud-based providers, Linux-based systems, and ability to ingest data from different areas and then store it in a complete stored solution. Now, once the data is ingested, imagine you have connected all the devices and now you are storing the data. Once the data is ingested, the next important area which is used in the data science parlance is called as exploratory data analysis. It is called as exploratory data analysis. So what we do in exploratory data analysis, what we are doing here is, once I have the raw data, I have to transform the data so that it can be in a consumable format. I should be able to consume this data in a nicer way. So this entire data, whatever is in the raw format, I should be able to consume that in a consumable format. So to make that happen, what we are trying to do is, you basically you can apply a lot of data pre-processing techniques. There are a lot of data pre-processing. So we have something like scaling techniques, encoding techniques, data cleaning, data transformation. We do something called as missing value imputation. Yeah. So there are a lot of other techniques like standardization. So what we are trying to understand here is, once the data is in the raw format, I can't use the same raw data for my machine learning model, right? So I can't use the same raw example, raw data in the machine learning models. So what we want to do is, we want to apply some kind of transformation here. We will be doing some data pre-processing, some scaling techniques, encoding techniques, data cleaning, some transformation. There are some missing value imputation. So all these techniques will be applied on the data, so that my raw data, which is in a very, very raw format, can be transformed into a consumable format. Got it? I can't use the direct raw data, because it might be having some unimportant information, non-value information and other things. I don't want to take that entire garbage and build my model. So if I use that garbage data to build my model, I will get garbage result. If you're having garbage in, you get a garbage out. So what you want to do is, you want to reduce the amount of garbage in your data. So you want to clean the data as much as possible, so that you can create in a consumable format. Now once you have a clean data, the models which you build using the clean data, it will be even better. So what you want to do, you want to perform this exploratory data analysis, where you want to understand what are the important fields, what are the non-important fields, which data you can keep, which data you can remove, how much data you have to pre-process. Do you want to expand the data? Do you want to compress the data? You want to apply some encoding techniques, scaling techniques, standardization techniques. Likewise, there are 100 different techniques which will be applied, so that you can clean your data. So you prepare in a way so that it can be consumed by your models. So once the raw data is cleaned, once you're creating in a consumable format, that will be fed to your modeling. The next technique will be called as modeling. Modeling is an area in which you use algorithms. So modeling is an area in which you use algorithms, and these algorithms, there are a lot of algorithms. There are supervised. Within the supervised, you have classification, you have regression, And then you have unsupervised techniques. Within unsupervised, you have clustering, you have something called as market basket analysis, something called as principal component analysis. Then you have reinforcement learning. So all these models like supervised, unsupervised, reinforcement, all these things are part of this modeling techniques. They are different algorithms. So if you ask me, there are like 100,000 different algorithms which are used. A lot of algorithms are there. If I want to name a few of them, so we have k nearest neighbors, decision trees, random forest, support vector machine, gradient boosting, XGBoost, logistic regression, linear regression models, support vector regression, random forest regression. Likewise, there are different types of models are there. And in unsupervised also we have k-means clustering, DB-scan, hierarchical clustering. Likewise, we have different kinds of models and techniques which are used for both supervised and unsupervised technique. And the primary purpose of these algorithms is try to make sense of your data and then try to create some kind of pattern by which it can do future predictions, right? So we are taking the data from the past, we are trying to understand the patterns of the data, and then using that patterns, we are trying to predict what is going to happen in the future. That is the purpose of this modeling. So this modeling, you will try to do a lot of parameter changes, you will do apply a lot of tuning, you will try to run multiple iterations and so on. So there is a technique called as hyperparameter tuning, which is applied in the modeling. So hyperparameter tuning, hyperparameter tuning is a technique in which you are changing some of the parameters of your model. So there are classification models, regression models, clustering models, and so on. You try to change some of the parameters of the models so that you can tune the hyperparameters. And then once the hyperparameters are tuned, then you will fit the model in such a way that your modeling will perform better and better. The modeling, what it will happen is it will perform better, and you could apply these modeling techniques in which you could train this model in such a way that you could create much more accurate results by tuning these hyperparameters. So you are kind of changing these knobs in such a way that you are trying to tune these parameters in a much more accurate way, so that these algorithms will perform better. Once you have the model ready, so after you do the hyperparameter tuning and after you run all the algorithmic changes and all of that, the final outcome will be your model. Most of the data science programs, whatever you see, you would see that they will be applying some XYZ algorithm, and then you get some result, and then you get some accuracy, and then say that this is what is data science. But that is only a small portion of the data science. The actual data science is also deploying those models. How do you deploy the models into production? What are the important tips and tricks, or what are the important uh, takeaways in which you would be using for deploying the models into production? So I will take an example of a cloud. Say I could say like an AWS cloud. So once the model is ready, we will deploy the model using some tools like Flask, Docker, and so on. So this model will be deployed as an API. Now, what is an API? API is called as an application programming interface. So API will be having some input output parameters. It will have an endpoint. So in the cloud, you will be deploying the model as an API, so that this API can be consumed by other systems. For example, there is a website which is consuming this API. The website is for some bank, ICICI Bank. Okay, And what this bank is doing is it is collecting some information from the users. What is the age of the person, what is the salary of the person, the bank balance of the person, and then it is having a submit button. So there is a submit button, and what this will do is it will call this API. It will pass all the parameters of the person who is applying for the loan. A person is applying for the loan, and then he or she wants to know the loan eligibility. So there will be salary, there will be bank balance, there will be a lot of other things. And based on all those things, what we are trying to do here is you are trying to call this API, and the API will be doing all the interactions. So API will be taking all the parameters, it will be calling the internal model, and then doing the prediction. So for a given bank balance, for a given salary, for a given loan eligibility, for a given credit score, you are eligible or not eligible. So the first condition is we are doing a classification problem, whether the person is eligible for loan or not eligible for loan. So that is a classification technique. We will try to apply that. So imagine the person is eligible for the loan. Next, we will apply a regression technique to understand how much the person is eligible. So is he eligible for 2,50,000, 8,38,000, 10,22,000, or 25 lakhs? So depending upon the different capabilities, the salary and different other things, the person will be eligible or not eligible for that loan. So what we are doing, these front-end systems, they could be developed in say Angular or React or maybe Java or whatever. So they are developed in whatever technologies, but they will be interacting with the API. API will be having an endpoint. They will be interacting with the API, and this kind of technique is called as real-time inference. It's called as real-time inference. So it's not only web applications, you could also have mobile applications which will be calling the endpoints, and that endpoints will be serving the model. They will be doing the prediction. It will take the input parameters and it will do the output prediction. And using those prediction methodologies, you would be able to do this kind of a call. Right? So that is one kind of inference. It is called as a real-time inference. There is another inference which is called as a batch inference. Now in the real-time inference, we are calling one at a time. A user is logging into a website or opening up a mobile app, and then he or she is calling internally in the backend. This API is being called. But in a batch inference, you will be scheduling a job. So there will be tools like Jenkins. So you'll be using the tools like Jenkins and all for scheduling the job in a batch mode. In a batch mode, you will be scheduling the job, and what this batch inference will be doing is it will be calling the same API. It will have a similar API, but instead of the API getting called in a real-time mode, it will be called in a batch mode. You will schedule this job, say like for example 1 a.m. in the morning, you'll schedule the job, and it will take an input file, and then input file is provided by some bank clerk. So they will have say like 100 person data, which is who are applying for bank loan. So you'll have that input file. So that input file will be fed to the batch model, and that will take every record and then create an output file. Output file will have for every record in the input file, it will predict whether the person is eligible for the loan or not. Right? So we'll be taking all the input details, and for every person who is applying for the loan, we are trying to see like whether he or she is eligible for the loan or not, and then you would get an output record. What will the output record? It will have all the people who are eligible for the loan, and for all the people who are eligible, what will be the loan amount which can be disbursed. Now that is happening in the batch mode. So this is running on a scheduled timing. So it will run maybe like every day in the night, or maybe once in a week or once in a month. Likewise, we can schedule, and this is called as batch based inference. Last but not the least, there is another important area which is important. It is called as data visualization. So data visualization is a technique in which we are trying to visualize your data. We're trying to say like how my data is important, and how you can visualize your data. You can apply some stories. You will be able to showcase some kind of results and so on. So that is called as data visualization. And we will be able to, in the data visualization, we will be able to use some tools like Tableau, Power BI, or we will be able to use other tools like Matplotlib or Seaborn and so on. So there are different kinds of tools which will be used for applying this data visualization. So where will this data visualization be done? It will be done at the start of the data analysis, where we are doing the exploratory data analysis. We would like to do this data visualization to plot some graphs and charts and other things, and then uh, we would like to see like how all these different kinds of charts and plots will be plotted, right? So we will perform this exploratory data analysis and perform this data visualization so that we can understand, what is the data telling. So the exploratory analysis, it is very, very important, because when so there is this proverb, like pictures speak more than 1,000 words, right? So if you are able to visualize the data in some kind of a graph or a chart, right, and you will be able to get more insights from the data rather than you just give an Excel sheet. Imagine some higher up official, he's asking like, how are the sales of Maruti cars in the last year, right? So if there is an official who is asking this question and we want to visualize the data, if I give him all the sale records for all the months in an Excel sheet which is having some 1,000 records, then he or she might not be able to make sense of the data, right? It is just some numbers. He or she might not be able to get any insight from the data. So instead of giving them an Excel sheet, if you plot the graph in a chart, saying that there are more number of car sales in the February 2020, and then after that there is this lockdown, there is a dip in the sales, and then slowly after July and August there was again an increase in the car sales. So that will show kind of an visual representation of what is happening with the data, and that can be possible by doing data visualizations. There are some connected tools like Tableau and Power BI and other things which are very popular nowadays. They will be used for doing these data visualizations, but primarily those visualizations will help us to tell some stories about our data, right? I've completely filled this entire notebook, but what we are understanding is, right from the starting, we did understand that we took a use case, a retail use case, and we saw that how the data used to store in RDBMSs. For doing the exploratory, for doing the descriptive analytics, how we used to run SQL queries, and then we used to run these nightly jobs because these queries were hampering my actual performance of the data. And then we understood that how these nightly jobs has traversed into data warehousing solutions. Now the data warehousing solutions were used for many applications. Even in nowadays, we will use for the structured data, we still use the data warehousing solutions. We will use those reporting capabilities, we will use the graphing capabilities, chart capabilities, and so on. But one problem we have is that they are not, nowadays they are improving, but they are not able to store unstructured kind of a data in terms of images, videos, log files, sensor data, textual data, all those things. For storing all these kind of pattern of the data, now we want some kind of solution to store. Those are called as data lakes. Then we understood about Hadoop, AWS, Azure, and GCP. There are different patterns of data lakes created. Once the data is in the raw format, then we can apply exploratory data analysis, where we can do data pre-processing, scaling, encoding, cleaning, and other techniques. Once the data is in the clean format, then we'll apply the modeling techniques. There are plenty of models. So throughout the course, our focus is to understand what different types of models are used, to what type of data, which model to apply. How do you hyperparameter tune the model? How do you create better version of a model? Which models are better than others? And which situation, what type of model to be used? So all these kind of important things will be discussed during the course. So we saw that there are supervised, unsupervised, and reinforcement learning techniques. And once we get into those all other areas, and once we create the model, the next step is to deploy that model. And many of the real-time applications are involved in how these models can be deployed, where they can be deployed. Either they can be deployed on-premise or on the cloud providers. Nowadays, most of them are shifting towards cloud. So we have AWS, Azure kind of cloud providers, where we can deploy our models. Once the model is deployed, then how do we create an API out of it, and how do we interact with that API? So there is the real-time API and a batch-based API. So this real-time API, where we can have this inference, where we can link to this model, and then we can use this model for doing a real-time inference. And once the real-time inference is done, we can integrate the endpoints to a web application or a mobile application, and which can call the model, get the prediction, and then can show it to the users. The inferences can also be done in the batch mode, where we have some kind of scheduling to be done, and these batches could be run. It could take the input data, do the processing, and then provide an output data. We also discussed about data visualizations, where we can use various tools like Tableau, Power BI, Matplotlib, Seaborn for doing a lot of processing. Right? So any questions on so far whatever we had discussed in the entire topic? We have run almost like 45-50 minutes now, non-stop. Any questions are there in this topic? Are you able to understand this, guys? You can use the chat window and you can post the questions. Right?
Yeah, Sitaram Garu, sorry to interrupt you. Hello everyone, this is Lakshmi from Career IT. Important info from our end. The regular sessions will be starting from Monday IST, which falls on Sunday for ESA people, and the timings will be from 6 to 7 a.m. IST. For more details, you can reach us on the numbers whatever I have provided in the chart. Thank you. Yeah, please you can continue, Sitaram Garu. Thank you.
Okay. So yeah, important information to note: the batch would be starting from 19th July, Monday, IST. So depending upon your time zones, you can know like what is the time zone for you, but it is at 6 a.m. IST. So I'll talk about a little bit about different things which would be covered. So I'll be giving a little gist about how the course would be structured. So this recording, so every day the session will be recorded, so you would be getting the recordings. So whoever who might have missed a portion of this class, don't worry, you would be getting the recording so that you can understand that. But I'll just give a gist of the course. It would be roughly around 2.5 to 3 months course. So you'd be getting a course curriculum. Reach out to the Career IT folks. They'll be helping you to provide the entire course curriculum. It is a very jam-packed course. So you'd be doing at least 20 plus mini projects. It is a project-oriented course. It is a technical course. So it's not like not like a basic understanding of data science or good things about data science. Definitely you can get that kind of information everywhere in the internet, but what our focus is that we need to do a lot of project oriented training. So when you do a project oriented training, what happens is you will be able to quickly understand. Even when you get into the projects, you get a opportunity, a job in as a data scientist, you will be able to quickly understand what is happening, and then you will be able to get up to speed. So we'll be doing 20 plus mini projects, at least 2 plus major projects, capstone. So this will be a practical course, as I said. So we will be having the video materials. You have codes, data sets, all those things provided to you. At the end of the course, we'll also be focusing on interview preparation. So people who are, who are ready for any interviews, we could get into the interview preparation and do that. And this will be like a daily class from Monday to Friday. So Monday till Friday. If it is like US, that will be from Sunday night to Thursday night. This is for US folks. US and other time zones, like whoever in the other time zones, US, Canada, and other time zones, this will be their timing, Sunday night to Thursday night. But generally, it will be from Monday till Friday, 6 a.m. EST. 6 a.m. IST. Okay, that is the course, and the duration will be 1 hour. In this 1 hour duration, we will be having 45 minutes for the session, plus 10 to 15 minutes for doubts. Mostly this is how the structure would be. You would be having a 1 hour duration session. 45 minutes I will be catering for the content of the session, and then we will allow at the end, we will have like 10 to 15 minutes doubt clearing session, so that if any persons who has doubt in that particular day, you can clarify those doubts, right? So this is how it is required. So what are the prerequisites? So somebody who has knowledge of basic coding is required as a prerequisite. I would recommend, if somebody has a knowledge of Python, it will be very easy, because we will be touching upon the Python which is required for data science. So I'll be covering Python for data science, but for a language part, like, I will not be talking about how do we define Python variables, what are classes, what are lists and dictionaries, and how do you do loops and other constructs. So those all things are more coding perspective. If you are familiar with any other language, it could be C or C++ or any other things, your basic understanding of any other language is good enough. If not, what you could do is you could parallelly take a course on Python, or you can brush up yourself, do whatever. You could do a parallel course. You could also get in touch with Career IT folks to check if there is any parallel course running on Python. Many of my previous students have done like that, where, if they are not really comfortable with the language, they could do a brush up refresher course, and they'll be getting up to speed. So this is the prerequisite. You need to understand about Python. We will be covering all the application areas. So we will be covering machine learning, we will be covering deep learning, we will be covering natural language processing, we will be covering supervised learning, unsupervised learning, reinforcement learning. Likewise, there are different kinds of internal things which are used. Our focus will also be on the basics. In the first few weeks, we will be talking about mathematics for data science. We will be talking then data science. Then we will be talking about statistics. Then we'll be talking about Python for data science. So these are important topics which we need to be covered. So first a few weeks, we will be talking about mathematics required for data science, statistical components which are required for data science, and Python which is required for data science. These are some of the important things. Once we complete all these topics, then we will get into the artificial intelligence, machine learning, deep learning, natural language processing, recommender systems, supervised, unsupervised learning, and so on. So those are the other topics which we'll be covering after we do all the basics, right? So this is the gist about the course. Around 3 months of the course, 20 plus mini projects. We'll be doing 2 major projects. You'll be getting a certificate, right? After you do the course, you'll be having video materials, codes and data sets. You'll be helping in the interview preparation. It is a daily course, 1 hour every day from 6 a.m. to 7 a.m. IST, and we'll be covering the ML, DL, NLP, supervised, unsupervised, all those techniques will be covered throughout the course. If you want to get into the details about what are the topics, you can get the curriculum from the from Career IT folks. They'll be helping you to provide you the curriculum. There you can look into all the topics. I have also listed the 20 plus projects, mini projects, which we will be doing. They are in different verticals. We will be doing projects on retail, healthcare, manufacturing, social media, e-commerce, and you name it. We are doing projects on every areas. And I also recommend people who are working to come up with their own specific use cases, their own projects, so that we can solve those projects using data science. And that will help you. In the previous my courses, many of my previous past students, what they've done is, in their own companies, they have some use cases, so they have come up with these use cases. So we have solved those use cases, and that helped them to crack the job pretty easily. So that is how we have to target. Okay, so the primary focus of this course is to get you the required knowledge, get you the required skills to get into the area of data science. Now we do not want to waste your time and my time, effort, money, everything. We don't want to be wasting all those things. We want everybody to be very much focused, so that whatever is required for getting the knowledge, getting the understanding, getting into the new job role or any other things, we will be putting our 100% effort so that you get into the right place, right? Any questions in this particular timelines or any of these things?
Yes. Hi. Question actually. I don't have any development background at all. I'm more like a functional project manager slash consultant. So do you prefer that I learn Python first and then join this course, or how can I parallelly?
Yeah, it depends upon your time. For example, many of my past students, as I was saying, Python is like a 1 month course. It's like a quick refresher kind of a course. So if you're willing to do, you could do Python as a parallel thing, and then join the course. First month of our course would be more on understanding the mathematics, statistical points. So it will be more of a theoretical, and by the time you learn the basics of Python, we will be getting to the Python for data science. So that is how generally you can plan it. But if you think like, no, I don't have time, and I need to really give good amount of time for my language skills, then you could do Python first, then come to the data science, right? That depends upon your flexibility and other things. But I know like many people do both in parallel, and quickly get up to the speed. In fact, we will also be talking about Python for data science, but we will be talking about how do you use Python in the data science parlance. Now, I'll not be talking about the variables and other things. We will be talking the language. How do I use that language to write some data science related things and so on. Understood?
Hi, Sitaram. This is Satish. So, seems like you have touched the basics of SQL in the automated deployments of machine learning models like Kubernetes and Docker. So, in your point of view, like, what do you think? So, a typical data scientist should have. I mean, I'm asking about the skills that the typical data scientist should possess.
I'm barely able to listen to your voice, but I understand that your question is about deploying, Dockerizing, and scaling up the models
Right.
and so on.
Right.
Yeah. So what my thought process is, I talk about this T kind of a structure. So I say a T kind of a structure, which is important for data science, where you have depth and breadth. So in the breadth part, in the depth part, we need to focus on the data science. So all the modeling part, data preparation, exploratory data analysis, all those things, whatever we've discussed, that will come in the depth part. And in the breadth part, you need to know about cloud computing and DevOps. Now they have given a new name called as MLOps, but I would call this as DevOps, which will talk about Docker, Kubernetes, and Jenkins, or Git and related deployments, continuous CI/CD deployments, and so on. So all these topics. Now, I'm not saying like you have to become a master of this, but you need to have familiarity about, now, if I deploy a model, how do I deploy it as a Docker container? How do I scale my Docker containers using Kubernetes? If I want to schedule jobs, how do I create a pipeline so that I can create the jobs using Jenkins? How do I push my code? How do I do versioning? How do I do code versioning, model versioning, and other things? All those things have to be understood, and that is really important. And I don't see many people talking, people are only talking about data science and getting accuracy and so on, but this is also very, very important, and you have rightly pointed out that this is important. On the other way around, cloud, because now everybody is moving towards cloud, I would say at least you need to have an understanding of AWS or Azure. So again, here we are not saying that you become master of cloud deployment on all those things. What we are saying is, if at all I have a model, I have an application, how do I deploy that model or an application, a machine learning model or an application in AWS? How do I create APIs so that I can create the API endpoints which are deployed on these cloud platforms? So we will be concentrating on these areas. So I have a specific section where I call it as cloud computing, where we will be focusing on all these different cloud related topics. And then I have a specific section which is DevOps for data science, where we will be concentrating on these areas of Dockers, Kubernetes, Jenkins, and other things, so that we can deploy end-to-end models.
So we'll be covering only a depth part in this course, right?
All the tests. What is it? Say again.
So we'll be covering only the depth part in this course, right? Not the
We
breadth.
will be covering both depth and breadth. Both of them will be covered.
Okay, great.
More focus on the depth, but we also focus on the breadth part.
Great, yeah, that's what I wanted, because I also wanted to learn about the MLOps and all. So since you already answered that question, so I think I'm good with that. Yeah.
Yeah, without that, it is just a half-cooked meal. You
Right.
can't.
Yeah. That's the reason I asked that question. So it's grateful that you are including these concepts in this course.
Yeah. Any other questions, guys?
And
Yeah.
one
So
quick question.
this is Narayana. So I have a question.
Mhm.
I mean, in fact, two questions. So first question is, if the Java developer, right? I mean, if I know purely the complete Java developer, and I don't know
Mhm.
Python, will that suffice, or how that would be?
Any programming language is good enough. Doesn't need to be Python. See, when I'm saying, we are not talking about variables and other things. We will be learning about how to use Python as a language for data science, but I will not be talking about the basics of that, right? So if you know any other language, doesn't need to be Java. It can be C, C++, C Sharp, or any other language for that matter. If you have an understanding of that, it is good enough,
Okay.
right?
Okay. Got it. So the second question would be, I mean, I'm in MSc zone. I don't know when the course has been started today. When I started at 8:30, for me it's 8:35 now, so 8:38. So what is the exact time that you're starting it?
Which zone are you? MSc.
MST, that is Arizona MST zone.
Okay. So you central time zone, right?
No, no, Central Time Zone. It's not Central Time Zone. It's Arizona MST zone.
Okay,
Right now
fine.
for me it's 8:30. So India is at
Yeah.
9 o'clock, 9:10
No,
something.
it will be at the same time then. It will be 6 o'clock my morning will be your 6 o'clock in the evening. So that is how it will be. So timing will be 6 o'clock to 7 o'clock IST morning, which will be your evening time.
So can you repeat it? 7 o'clock IST, right? You said.
6 o'clock to 7 o'clock IST. 6 a.m. IST, which will be whatever your time zone. You can just Google it. You will
Okay.
be able to
Yeah,
get it.
yeah, I can do that. So six. That
Should
is
be
6:30.
around 6:30 your time.
Right. So today we start at 6:30.
No, no, no. Today we had a demo only. So we started at 8 o'clock, 8 to 9. So this is
Oh,
a demo session to just give a brief about what are the different topics. I think you have missed the main part of it,
yeah,
but you
yeah.
can get the recording. So we discussed about a good 1 hour on what is the end-to-end life cycle of data science, which are the important parts and so on. So you could go through the recording, you'll get an understanding of that.
Okay. Yeah. I can get the video, right? I mean the recording session.
Yeah, yeah, yeah. You should.
Yes, I'll
Okay.
be sharing the recorded session and the timing would be 6:30 for MST people, 6:30 p.m. For IST, 6 a.m. from Monday. Hello?
Yeah, yeah.
Yeah. Got it.
Yeah, time will be 6:30 p.m. regular session timing for MST people. I'll be sharing along with the timings of CST, MST, PST, all the zones I'll be sharing.
Yeah, that's
Okay,
what I want.
time zones also.
I got the message that MST on it's 8:30. So I joined at 8:30. Thought it started.
No, demo,
You want
right?
to
This is demo. That would be demo timing. Today's demo timing, but regular session timings would be 2 hours back to that time.
okay, yeah, got it. Got it.
Okay, fine then. Thank you. Yeah.
6:30 IST, so I can make it myself. Okay.
All right. Any other important questions, guys? Any other general questions also? We can spend few minutes to discuss about that.
So we can cover the retail, data science as well, right? I don't know. I joined late, so I can understand that part.
Could you repeat the question?
When you talk about the data science, you will be covering the cases of retail industry as well, right?
Use cases. Yeah, yeah, yeah. Retail also we are covering. We will have retail, banking, insurance, manufacturing. So we have different use cases. So we'll be doing 20 mini projects. So in that we have a couple of retail use cases. If you also have some use cases, for example, your company is doing some work on that, you want to put some retail use cases, we are open to work on those cases also.
Okay, yeah, I need that. So actually I work for real retail, so I have some cases as well. We can, yeah, thank you.
Yeah, definitely, we will be happy to do that. All right, any other questions? All right, guys, so I hope you got some understanding of this entire end-to-end life cycle. So from Monday, we'll be starting the class. I'll be talking about the basics of applications of data science and all those things in that session. But we will take deeper concepts, and we will get into the deeper areas of machine learning and so on, as and when we go deeper into the course. Okay. So if you have any questions, I'll be happy to take a few questions.
Sitaram, one last question. So you said you'll be covering NLP, right? So you'll be covering the basics, or you'll be covering the full concepts of NLP? Because I'm interested to learn to the extent of NLP as well.
Yeah, so NLP as a field, right? There are a lot of in-depth concepts in NLP. So what we will be covering is basic to intermediate, I would say. Intermediate level we'll be covering. We will create like how do we use different natural language pre-processing for data sets. How do you predict models using NLP? How do you convert textual data into a machine understandable formats? And how do we implement models on that? So we will be creating projects using spam detection, text summarization, sentiment analysis, and these are some of the projects we'll be doing. And we'll be learning those NLP concepts using the projects, right? So that is the focus. But NLP itself is a vast subject, talking about different languages, different constructs, and nowadays a lot of newer tools are coming into the market, the birds and transformers and other things. So those are going into too much detail. If you want, what we will do is we will run some workshops which will cover these advanced concepts of different areas. So we have computer vision, we have natural language processing, you have chatbots and other interesting application areas are there. So we will be running some workshops which will be covering those topics, but as a part of the course we'll be covering intermediate level of NLP, because this
Right.
will be a complete 3-month course, right? So if I go talk on NLP itself, it will take more than a month, and not everybody will be interested, right?
Okay. Yep. But still, that was really that will be still a lot of productive things. Yep.
Yeah. We will be covering all the important ones which we are doing in the industry. But if
Yeah.
you have a specific use case where we want to deep dive, everybody is interested, then we will go it. That's how I take. It's more of a on-demand basis things, right?
Right. Yes. Okay. That's all for my side. Thank you.
Great. Any other questions, guys? All right, wonderful. So I hope you liked the session. You got some information, I hope. So I would happy to see you in the course. If you have any questions related to the course or anything of that sort, you can get in touch with Career IT folks. They'll be happy to help you with any of the information. Any technical questions, you can reach out to me and you will be able to get all the doubts cleared. Okay, have a nice weekend, and we'll meet on Monday. Thank you very much.